Hi, good evening. So welcome back to our EV channel. Today we are going to conduct an experiment how to connect a convert a three-phase supply to two-phase supply, where this connection is called as SCOT connection. Coming to the circuit diagram, so here you are going to have an three-phase supply. So you are having R terminal, Y phase and B phase and neutral. All these three inputs we are going to connect to an a auto transformer, and output of the transformer we are going to take R phase, Y phase, B phase, and we are going to interconnect two transformer. First transformer is called as laser transformer, and next transformer is called as main transformer. To this laser transformer, at 80% we are going to have one tapping, and 0% tapping we are going to connect at the center of another transformer, where center means, for example, here I am applying 0 volts. The center for this is 115 and the output for this is 230. So from this 0, if we connect to the center, so this is the primary connections of the transformer. The secondary connections of the transformer, we are going to connect 1 voltmeter. To the secondary connections of this main transformer, we are going to connect one more voltmeter. This voltmeter measures V22, and this voltmeter is going to measure the voltage V21. The vector of V21 square plus V22 square will give you the value of V23. So here you are going to connect from 230 to 0, and you can see here these are there in series additive. Therefore the resultant voltage you are going to get, which is nothing but V23 is a vector of V21 as well as V22. So this connection is generally useful when you want to industrial appliances to convert a three-phase supply into two-phase. This connection plays a major role. Let's try to see the connections. You can see here. So first, so I'm taking three phases from the supply. So this is nothing but R phase, this is nothing but Y phase, this is nothing but B phase, and this is nothing but the neutral. All these three-phase supply I'm giving to an input of an auto transformer. So this is nothing but the input of the auto transformer. Now I have to connect to the teaser transformer. So from R, so this is nothing but R wire. So here you can see here, this is nothing but R, this is nothing but Y. So these are the output terminals of the transformer. So here you can see the output terminals of the transformer. We are going to have this the output terminals of the auto transformer. This is R phase, this is nothing but, next one is yellow phase, this is yellow phase, and this is nothing but blue phase. Okay, so you are going to have R, Y, B. So how to connect is already discussed here. So R we are going to connect to the teaser 86%, and Y we are going to connect to the primary of the another transformer, and B we are going to connect to another terminal of the transformer. You can see here this transformer is called teaser transformer. Here we are going to have the tapping of 86%. That's why connected an R here. Next one R, Y. So this is nothing but Y. You can see here Y I am going to connect at 0. Okay, the next 0 of the transformer, and next at 230 I am going to connect the B phase. Okay, so this is nothing but the B phase of the transformer. So now let us try to execute how it works. Okay, so coming here. Hi everyone, welcome back to our EV channel. So today we are going to give the connections for SCOT connection. This is nothing but the input to the auto transformer R, Y, B we are giving to the input of the auto transformer. So here you can see the output of the auto transformer. So here you have the R, Y, B to the input of the auto transformer. Output you are going to have R, Y wire and blue wire output of the auto transformer. So here we are going to convert the three-phase supply into an two-phase supply. So this is very important for farmers. So sometimes they need to operate some motors with two-phase, or this is very important in industry also. So we require to conversion of a three-phase to two-phase, which plays an major role for their industrial applications. So that's why we are going to convert this three-phase into two-phase. Let's try to see here. So here this is nothing but we are giving this main transformer is called teaser transformer. This transformer is called main transformer. At 80% of the tapping we are going to connect R phase. At 0 voltage we are going to connect Y. So at 0 we are going to connect Y, and at 230 we are going to connect one more phase R, Y, B, and to the secondary of the transformer. So you can see here two colors are there, to secondary of the transformer we are connecting to 1 voltmeter, and the secondary of this transformer we are going to connect 1 voltmeter, and the output of the one winding we are short it with this. We see this output of the winding, so the 230 volts we are bringing and we are shorting to 0. This is nothing but acts as a connection between the secondaries, and the vector this is going to measure V22 and this is going to measure V21, and this vector is nothing but V23. So these three should be in front of vector group. So where if you draw the vector diagram, here we are going to have V21, here we are going to have V22. So the vector is nothing but V23, and this V21 and V22 will be phase shifted with 90 degrees. This and this will be phase shifted with 90 with respect to this, and this is going to have the resultant voltage 0 to 600. Okay, so you can see here 230 to 0 have been connected, and I am measuring the voltage from 230 1 voltage, and next one the neutral I am connecting to 0. This is going to give the vector. If these three are in vector group, automatically I can say that we have been successfully transformed a three-phase supply into an two-phase supply. Let's try to do the experiment. So let us see the basic calculation. So we are going to apply some sort of 100 volts. Okay, so just turn on the supply. So we are going to turn on the supply. So automatically it will indicate the line to line voltage is nothing but 200, I mean 400 volts, 390 volts approximately. Slowly we can see this variation. So this is nothing but connected to 300 range, but the base scale is 150. We are multiplying two times. So this is also base scale is 150. We are connecting to we are connecting to 300, so it is multiplied two times. So that voltmeter is also connected to 150 and we are multiplying two times. The vector of these two, the sum is nothing but this one. So this is connected to 600 scale, that's why you have to product two times. This is nothing but V21. So this voltmeter is nothing but V22 group, and this is nothing but V23. Just for clarification how we are going to apply. So here I'm going to apply a voltage of 100 volts. You can see all the 3 meters how the direction they are going to. Here I have to apply 100 volts, but it is scaled two times. That's why I have to apply only 50 volts. So you can see here the meter is going to show you the required voltage of 50. Okay, so here you can see here input is 50. So 50 into 2. Okay, or let's try to go with 100 volts. So I'm going to apply approximately some 80, or let's try to go with some minimum voltage where we have more safety. So 100. So 100 into 2 is, sorry, 50 into 2 is 100. And here when you come to this transformer, this is V21. So this is 25 into 2. So we got the value V21 is approximately 50 volts, and V22 is equal to the same 50 into connected to 300 scale. This is 2, which is nothing but 100 volts. This is showing it as a 25, as well as it's connected to 300. You have to multiply 4 times, which is also equal to 100 volts. Okay, here you can see here this is also 100, that is also 100, and when you observe this resultant, you are going to have 31, 32, 33. Okay, so which is nothing but 33 into is multiplied with 4 times. So now 100 square plus 100 square, and we have to perform root of this. We are going to get which is nothing but 33 into 4. When you perform it, this is also equal to, so 33 into 4, the same voltage approximately 120 volts or 100 volts you are going to get. So when you perform this, you can get in clarity. So approximately, so here you can see that V21 square plus V22 square, so which is also is equal to V23 value. So where I can say that now we successfully transformed a three-phase supply into an two-phase supply, and V21 and V22 and V23 are in vector group, and I can say that we have been successfully transformed a three-phase supply into an two-phase supply. This is all about the experiment, how we transform a three-phase supply into an two-phase supply. So hope the video is useful. Please share with your friends and try to promote our EV channel. So thank you for watching.